Okay, 4.1 day 2, we're going to start graphing polynomial functions, and this is a topic that is new for most of you. Okay, the first part of a polynomial, actually, let's rewind. What do polynomial functions look like when we graph them? When we graph a polynomial function, it's always going to be curved and it's smooth, something like this. There's no breaks, and it's going to be something curvy. Okay, the first part of a polynomial functions graph that we're going to consider is the end behavior. The end behavior just says, what do the arrows do on the left and the right? So on my little example here, the arrow went up on the left and the arrow went up on the right. Now in the middle, it might do all kinds of weird stuff, but the first part is we're only considering what happens on the left and the right. Okay, now what happens on the left and the right has to do with the leading term of the polynomial, or the degree and the leading coefficient. Okay, so for this first graph here, this has an even degree and a leading coefficient that is positive. So for example, that could be something like y equals, I want it to be positive, and I want it to be an even exponent. Okay, now it could have a bunch of other stuff after it, but it has to start with a positive and an even. If it's an even degree, it does the same thing on both sides. So even means the end behavior matches. The two arrows need to match. Since it's positive, it goes up. So it goes up on both sides. So if it's an even degree, it's going to go up on the left and up on the right. Now, of course, there's a fancy way to write that. Okay, so this says as x approaches infinity, negative infinity. As x approaches a negative number, so this is the x-axis, x approaches negative on negatives, means that this is on the left. On the left. Okay, on the left, what does the graph do? This is the y value. On the left, the graph goes up. Since it's going up, the y value is going to positive infinity. And this means up. Okay, on the left, the graph goes up. Now, it goes up on both sides, which means on the right, it also goes up. So when it says it's positive infinity, they're saying on the right, because on the right side of the number line is where the positives are. On the right, the graph also goes up. So we say that is going to positive infinity, and that means up. Okay, now if I have a graph that is still even degree, but instead the leading coefficient is negative. So for example, y equals negative 3x to this, let's do 8th. It could have a bunch of stuff after it. Okay, even degree is the exponent. Even means they match on both sides. Since it's negative, it's going to go down. Since it's even, it goes down on both sides. And you can see here, it's going down on the left and down on the right. Okay, the way we write that, we're saying on the left, I want to say the graph goes down. Negative infinity means it goes down. Okay, as x approaches positive infinity, on the x means the number line. On the number line, the positives are on the right. So on the right, the graph also goes down. Negative infinity. Okay, both of these had even degree. Let's look at odd. Okay, now if it's an odd degree, it might be something like this. Actually, does this have a positive? It has a positive. So maybe 3x to the 5th, the exponent's odd, plus a bunch of stuff. If it's an odd, it does not match on the left and the right. One side goes up, one side goes down. Odd is a mismatch. Okay, if it's positive, it goes up on the right, down on left. And I'd like to think of it as a positive slope. Positive slope is down to up. Down to up. A linear function is actually odd. So down to up. Down on the left, up on the right. Okay, now in the fancy limit notation, as x approaches negative infinity, on the number line, the negatives are on the left. So on the left side, this graph goes down. To say down, we say negative infinity. Okay, the second statement is x approaches positive infinity. So this is saying on the number line, the positives, they're on the right side. So on the right side, this graph goes up. To say up, we say positive infinity. Okay, one more rule. Okay, odd Odd means they're not going to match. One up, one down. Okay, the coefficient is negative. So this is something like y equals negative 3x to the, let's do 7. Odd, negative. Odd, mismatch, negative actually means it's going to go down on the right. Or it has like a negative slope. A line with negative slope starts high, goes down. This is going to be up on the left, down, right. It's like a negative slope. Starts high, goes down. Okay, as x approaches negative infinity, remember that means on the left, what does the graph do? It goes up, which means it goes to positive infinity. Okay, as x approaches positive infinity, on the number line, the positives are on the right side. So on the right side, this graph is going down. So to say down, we say f of x is approaching negative infinity. Okay, let's try some examples where we just read the end behavior, and then we'll actually put it with the graph so you can see why it's useful to us. Okay, so we're going to describe the end behavior of this polynomial function. Before we do the end behavior, we're going to look at the degree and the leading coefficient. So for a, f of x equals negative 0.5x to the fourth plus 2x to the third minus 1. I want the highest degree term, which is this one. That's the highest exponent. If it's not in standard form, it won't be first, so be careful. Okay, now I'm going to ignore the rest because I only care about the highest degree. Okay, now what's the degree here? The degree is the 4. That's the exponent. Okay, is that odd or even? Even, which means it's going to go up, up, or down, down. Okay, the leading coefficient, negative 0.5. So the leading coefficient is negative. Okay, even means it's going to match on both sides. Negative means down on both sides. So it's going to go down on both sides. Down both sides. Even matching negative down. Okay, now I'm going to write the limit notation like it's in the fancy way. So this is saying as x approaches negative infinity, on the number line, the negatives are on the left. So on the left, the graph goes down. Okay, as x approaches positive infinity, on the number line, the positives are on the right. So on the right side, the graph is also going down. Okay, let's look at the next one. B, f of x equals 2x cubed minus x squared plus 1. We only care about the leading term, or the highest degree term, which is this one. And remember, it might not be in standard form, so it's not always first. These ones happen to be in standard form. Okay, degree is the exponent. Degree is 3, which makes this odd. Odd means one side's up, one side's down. Okay, the leading coefficient is 2. Is that positive or negative? Positive. Okay, if it's positive, I'm thinking positive slope. Okay, starts low, goes up. Odd means they mismatch. Positive, it's going to go up on the right. Okay, now, as x approaches negative infinity, on the left, what's the arrow pointing? Down. As x approaches positive infinity, on the number line, the positives are on the right. On the right, it's an up arrow. Let's try a couple more, and then we'll get to the graphs. Okay, leading term, only the highest degree. Degree, 5, which is odd. Odd, it's going to mismatch, one up, one down. The leading coefficient is the negative 7, which means it's negative. If it's negative, negative slope, or down on the right. Okay, as x approaches negative infinity, on the left, we have an up arrow. As x approaches positive infinity, on the right, we have a down arrow. Okay, D, f of x equals negative x squared plus 5. Degree, 2, which is even. Okay, leading coefficient, it's negative 1. We just care that it's negative, though. Even means it's going to match on both sides. Negative means it goes down on both sides, which actually makes sense because this is actually a parabola that moved up 5. So it would actually look exactly like that. Okay, on the left, the graph goes down. On the right, the graph goes down. Okay, now we're going to try to graph. Okay, it says using zeros, end behavior, and extra points, graph the polynomial functions. Okay, this is the polynomial they're giving me. Let's look at the information they've given me. They're telling me the zeros. Okay, let's see, what are zeros? X equals -3, x equals -2, and x equals 0. When they say zeros, they're giving me the x-intercepts. So they're already giving me 3 points to graph. So I'm going to plot the zeros. Okay, x-intercepts, -3, 0. It's a sketch, so I'm just going to guess. -1, -2, -3. Maybe over here. If it's small, you could put the little dots there. I'm going to label it because this graph has no marks on it. Okay, -3, 0. What's the next one? 2, 0. 2, 0. And 0, 0. Okay, so I already have 3 points on my graph. This is a polynomial. So the graph is probably going to go, it might go like this. It might go like this. It's going to do something that's going to hit those 3 points. Okay, part 2. Graph the end behavior. Okay, the end behavior depends on the leading term. So now I'm going to only look at -x to the third. The degree, odd, because it's x to the third. The coefficient, negative. Okay, now if it's odd, they don't match on the left and the right. If it's negative, it's like a negative slope, so it's going to go down on the left, the right, and up on the left. Okay, now where do I put that on my graph? Okay, I have 3 dots here. Okay, on the right, it's going to go down. So on the rightest point, which is over here, it's going to go down. I don't know exactly what, but something down. Okay, on the leftist most point, it's going to go up. So let me do that. Okay, that's my end behavior. So now I just need to figure out the middle. It might go like this. It might go like this. It might go like this. Okay, but we're halfway done. Okay, I need to plot some extra points between the zeros. I don't need a lot of points. I just need to know, is it going to go up here or down here? So for example, between here and here, I'm going to plug in 1. I'm going to pick, I pick points that are convenient and that will give me enough information. Okay, so let me plug 1 back into the original function to get the y value. F of 1, -1, watch your signs. You don't need the parentheses, but you need to be careful. 1 times 1 times 1 is 1. What is that? -2 plus 6 is 4. Okay, so this is 1, 4. Now I don't know exactly where 1, 4 is, but I'm going to say it's up here. I'm going to go ahead and label it. But now I know this graph is going to go up, kind of like that. Okay, now the last part is between here and here. Is it going to go up again, or is it going to go down again? So I'm going to pick a point that is between there and there to plug in. And it's up to you which point. Maybe -1, -2. You could even do a decimal, -1.5. Pick something you think will be easy. Let's just do -1. So f of -1, it's going to have some tricky signs. -1 cubed. Okay, and make sure you use parentheses, okay? Because you're plugging in a negative. Okay, -1 times -1 is +1 times another -1 is -1. Minus -1 times -1 is +1. Minus 6. So this is +1 minus 1 minus 6. 1 minus 1 is 0, minus 6 is -6. So -1, -6, I don't need a good graph. I just need to know that it's going to go down around here. So now I know it's going to go down here, and it's going to go back up to my point. Okay, and then this is a decent graph for a polynomial function. I got the zeros graphed. I did the end behavior, and then between each zero, I figured out if it was going to go up or down. Okay, now that you've seen the whole process, let's go ahead and try the next one. Okay, so for B, they give me a giant polynomial. Okay, eventually we're going to figure out the zeros ourselves, but since we're still practicing our end behavior, we're going to go ahead and just use the given information. So I'm going to plot the zeros. Okay, You can put the marks or you can estimate. So -3, 0. -1, 0. And +2, 0. Good. Play with the zeros. Okay, the end behavior. Okay, end behavior. I'm only going to look at the leading term, which is the highest exponent, which is this one. The degree or the exponent is even because it's 4. The coefficient is positive. Even, they're going to match the end behavior. Positive means up, so it's going to go up on both sides. Okay, so I'm going to go furthest to the left and kind of make the graph go up, furthest to the right and kind of make the graph go up. Okay, I don't know what's happening in the middle, but I know far left is up, far right is up. So now I just need to figure out, in between here and there, is it going to go up or is it going to go down, up or down? Okay, so I want to pick some points carefully. I normally do the easier one first. So between -1 and 2, you could use any point in here. You could use a decimal, but normally an integer is easier. So 0 or 1. I'm going to do 0 because 0 is normally the easiest point to plug in if it's useful. So g of 0. Okay, I'll show you why 0 is easiest because you can normally do it in your head. I'm going to plug it in for the sake of our notes. But after that, you're going to probably do it in your head. Okay, the reason it's easy is if I do 0 to the 4th, I get 0. 0 times 0 is 0. 18 times 0 squared is 0. 0, 24. So it's 24. And I could have done that in my head because I would have been like, oh, this is turns 0, 0, 0. I'm left with 24. 0, 24 is somewhere high. This is just a sketch. So as long as I put it in the positive area and I label it, it's good enough. Okay, so what did that tell me? That told me the graph's actually going to curve up here. And then it's going to go back down. And be really careful. Your zeros are -3, -1, and 2. It cannot hit the axis any other place. So when I went to 2, I had to bounce straight back up so it didn't accidentally hit an extra point. Okay, so the last thing is between here and here, is it going to go up again or down again? So between -1, I'm going to do -2. I'm doing it because it's easy. You could have done a decimal if you would like. I try to avoid them when possible. 2 times -2 to the 4th, -2 squared, -2 plus 24. -2 to the 4th, 4, 4, 16, minus 18, -2 squared, 4, minus 16 plus 24. 36, 72. Should I add these up? I'm going to go ahead and add these up. 24 minus 16 is positive 8. So what is that? 32 minus 72 is -40 plus 8. So -32. Okay, and this is a sketch, but I know the -2, -32 is going to be down. And that's enough for me to get my curves going the right way. So I know this is going to go down. It goes back up and hits that 0. Okay, and then just double check. My zeros are -3, -1, and 2. So here, here, and here. I can't hit any other place other than that. The end behavior was even and positive, so it went up, up. And then I know that from here to here, it had to go up, and here to here, it had to go down. Okay, go ahead and try the practice graphs, doing all the steps we just did. If you get stuck, unpause the video, but really try it on your own so you can see where you're going to get stuck, if you're going to get stuck. Okay, I graphed my zeros, -3, 0, and 3. For my end behavior, it was odd with a positive coefficient, so it's like a positive slope. It's going to go up on the right. So on the far right, I'm going to make it go up. It's going to go down on the left. Okay, I'm going to pick some points in between. So between 0 and 3, I might pick 1, I might pick 2. Whichever one looks easier is the one you will plug in. I think 1 is easier. But if you think 2 is easier, plug in 2, and our graphs will be similar, even though they're not the exact same. Okay, for each of 1, I got -16. So I'm just going to estimate maybe 1's here, -16's down here somewhere. Just enough so I have verified that the graph is going to go down between x is 0 and x is 3. So something like this. If you plugged in 2, your graph also goes down. Our curves won't be exact, but we're both going to be going down. Okay, now from here to here, -3 and 0, I'm going to pick a point, -1, -2. I'm going to plug -2 in. And again, -1 in. And the only reason I'm picking 1 is because I think it's a little easier than negative 2. Some people think negative 2 is easier. Whichever one is easier for you is fine. Okay, for h of negative 1, I got positive 16, so it's going to go up. Okay, so this must go up this way and down this way. So your graph should be similar to this. You should have the zeros. Same end behavior, and it should kind of go up, down, up. Okay, go ahead and try the last one. Okay, so far I have plotted my zeros, negative 3, negative 1, and 2. This is degree 4, so even with a negative coefficient, so it's going to go down on both sides. So I did my down on both sides. I just need to figure out what's going to happen between the zeros. Between negative 1 and 2, I could do 0, I could do 1, I could do a decimal. I'm going to do 0. And again, it's because 0 is very easy for me. If you can plug 0 in your head, I'm fine with it. Let's look at it to show how I would do that. If I plug in 0 here, 0 to the 4th is 0, 0, 0, 11 times 0 is 0, plus 6. So h of 0 is just 6. If you would rather plug in 1, that's fine. 1 is not that hard either. So whichever one's easier for you. Either way, your graph should go up and then come down to the negative 1. Okay, between negative 1 and negative 3, pick a point to plug in. I'm going to pick negative 2. Okay, h of negative 2 is a tough one, but I got h of negative 2 is 4. Okay, check your work. You can always use a calculator to verify. So negative 2, 4 is up here somewhere. It's just a sketch. I just want to know that the graph is going to come up here and then go down. So check your graph. You could have plugged in a different point, but it should still start down, go through negative 3. There's an up hump, hits negative 1. There's another up hump, goes through 2, and then goes down. Okay, and you should be graphing these by hand, but if you ever want to verify your answer, you could always check it on Desmos. But just remember, you're going to have to do it on your own on your test.